Alrighty, we are now looking at number 5, which has the larger radius. Okay, we're looking at Al, which is aluminum, or In, indium. You definitely want to find those on the periodic table because these are just comparative statements. They're just comparative, comparing these two atoms, which one is larger. And so you want to find, hey, are these two things in the same period or are they in the same group? That way you know which trend to consider. Looking at the periodic table, are they in the same period or are they in the same group? They're in the same group. So you want to use the period trend for atomic radius. And that's as you go down a group, atomic radius increases. And so since indium is further down in the group, that means that indium is the larger. B, we have another radius question. It's calcium versus selenium. We find those on the periodic table. Calcium is in period 4. Selenium is also in period 4. So that lets us know that we're using the period trend here. They're both in period 4, so we're using the period trend. And that is as you go from left to right within a period, the radius of atoms decrease. Okay, so that means that selenium, being further to the right, is going to be smaller. And the question is asking for the larger radius, so that makes calcium the larger. Now we're moving on to ionic radius. And so we're asking the question here. This is about calcium and then calcium's most stable ion, calcium plus 2, which is larger. A line of reasoning you want to use here is calcium has lost 2 electrons in order to reach this positive 2 charge. The number of protons hasn't changed, has it? It's still calcium, so the number of protons is the same, so that the amount of nuclear charge hasn't changed. What's changed is you've lost 2 electrons. And I'm hoping we're getting the hang of this. When you have fewer electrons, when you lose electrons, the amount of shielding goes down. The amount of shielding goes down. And when your shielding decreases, the electron cloud can sink in. Okay, it can sink in towards the nucleus. And so that means that this calcium ion is smaller. Question is asking for which one is larger. So that means the original neutral calcium atom. The neutral calcium atom. D, which class is larger or has greater ionization energies, metals or non-metals? Now, you can either look in your book for these values of ionization energies. There is a table on page 145 that describes the first 5 ionization energies for elements in periods 1 through 3. Or you can use your trends. For example, ionization energies. Let me take one step back. I hope you guys realize you can use your period trend for ionization energy to figure this out. Because if you start on the left, and you go to the right within a period, do you guys also see that you're moving from metals to non-metals? You guys catch that? You rolling with me here? And so I can just use my period trend. So what's my period trend with regard to ionization energies? As I go from left to right, ionization energy increases. And so the largest ionization energy that I have is going to be on the far right side of that period. Are metals or non-metals on the far right side of a period? Non-metals. Okay, so non-metals, forgive my penmanship, and spelling, non-metals. Okay, E, which has a greater ionization energy, arsenic or chlorine? Again, let's find these bad boys in the periodic table. Here we find that they are neither in the same group nor the same period. So what do we do? Well, we still want to use both of our trends for ionization energy. We just use the period trend for ionization energy, and that says as you go to the right within a period, it's getting larger. What's the group trend for ionization energy? As you go up a group, ionization energy increases. So as you go up and to the right, ionization energy is going to increase. Well, if we start at arsenic, As, what directions do you have to go to get to chlorine?
Up 1 over 2.
Right? Up and to the right. Up and to the right. And that's the direction. Those are both of the directions in which ionization energy increases. So, out of these two, which has the larger ionization energy? Chlorine. F. An element with a large negative electron affinity is most likely to form. And I've talked to some of you already about this. Let's not go past what these words mean. I'm sure a lot of you have noticed that I have an affinity for food. Me likey food. Yeah, me eats lots of food. That means that I like food, and I want a lot of food, and I get a lot of food, right? I have food affinity. Well, if I change that from food to electrons, if I have an electron affinity, it means I like myself some electrons, and I want to get a lot of electrons. And well, since I'm important, I'm the boss here, I get a lot of electrons. And so if you're an atom and you have a large electron affinity, it means you get electrons. And when you get electrons, what charge are you?
Negative.
You're negative. Okay? Negative ion. All right, juniors can go. G, in general, which has a stronger electron attraction. Right, electron attraction, that's the same thing as saying electronegativity. Which one has a larger electronegativity? A large atom or a small atom? If we're looking at radius here, hope you realize that the edge of the electron cloud has been pulled in closer to the nucleus. And so you're able to get closer to the nucleus of that atom. You're getting close to the source of that nuclear charge. And you can feel that charge a lot more strongly if you're another electron. So the fact that you can get closer to the nucleus of a small atom results in a stronger electron attraction. So we're going to go with small atom. H, which has a greater electronegativity. So we have oxygen and selenium, and keeping in mind what we just talked about for G, which has a stronger electron attraction, a large atom or a small atom, okay, we can keep that in mind. We can use that for H. We concluded that a smaller atom has a stronger or a larger electronegativity. So we look at O, oxygen, and Se, selenium, and we see that they're both in the same group, but selenium is a couple of groups below oxygen. Oxygen being in, period 2, and selenium is in, my eyes are failing me, period 4. Okay, so that means that selenium is going to be larger. We just concluded that smaller atoms have stronger electron attraction. So which has a greater electronegativity? The smaller atom. So it's going to be oxygen. Okay, oxygen. I. In the covalent bond between selenium and oxygen, to which atom is the electron pair more closely drawn? And what you guys don't need to do here is get all worried that we haven't gone over covalent bonds yet. We're still going to use electronegativity to figure this out. And in fact, when we start talking about covalent bonds, we're going to use electronegativity to figure out what type of covalent bond it is, whether it's polar or nonpolar. So we only need electronegativity here. So if we were to bond an oxygen and a selenium together, that means that they're sharing electrons. Okay, that's all we need to know for right now. It means that they're sharing electrons. But if oxygen is more electronegative than selenium, that means that it is attracting the electrons more strongly. And so if electrons are being drawn towards oxygen more strongly when you compare it to selenium, that means that they are going to be closer. They're going to be closer to that oxygen, because oxygen is more electronegative. It is pulling on those electrons more strongly. J, how many valence electrons are there in a neutral atom of selenium? So find selenium. I see that it is in group 16 or main group 6. That's all I need. A neutral atom of selenium has 6 valence electrons because it's in main group 6, also known as group 16. But if I use that designation, I would have to subtract 10 to find my final number.